Okay, check muna ng TikTok. Ay, naku, nagbabadya na naman tong aso ko na tumae. Ang saya.
You want to open the window? Kahit siin ka? Open the window ka.
Hello, hello? Ayan, okay na. Kaso, wala yung docking. Lagi na lang kailangan i-dock. Ayan, okay na. Yan lang. Walang audio yung stream ko dito. Yan, I think this is good. Hey. Hey, good guy. Yeah, still studying. This will be. I think this will talk a lot of. This will take months for me to finish this book. But I'm still progressing, but a little bit slow. But yeah, but I have other also additional study tasks. So every other day I will do LLM, and then another every other day I will do uh, software architecture study. Sorry. Oh, okay. Earlier when I checked, the music is kinda low. Let me. Yeah. So my schedule for studying is a bit kind of change a bit. So I think Monday, Wednesday, I will study software architecture. Tuesday, Thursday, I will study building LLM from scratch. So probably it will make my study a little bit slow. But I need to study study software architecture because I have a potential side hustle that will need software architecture skill. So I need to keep studying since I think it's my first side hustle that I will practice software architecting. Even though I did it in my regular work, but yeah, for side hustle, it's my first time. Yeah, because I'm already working, so I'm trying to get more job as much as possible to be able to save for my to save more since I'm also paying a mortgage for a land loan. So I need to grind a lot. On my side hustle, more on software architecting, so more on consultant. Then for my regular work, as usual, software engineer. But they don't conflict since they are not on the same type of development. They have different category of development. But still, I need to make sure that they don't conflict. So I do it after work. Oh, okay. I see. Okay. I did full stack development on a year for a year, and now I'm employed. Company wasn't doing the fire. Uh, you don't have any any choice if a company is losing business. I hope you find a work because being unemployed is really kind of stressful. Oh, how do I make this one? Oh, okay. But this one is a token ID. Yeah, I think I missed something here because these are all token IDs. Not really. It's just the market is really super competitive right now. I think the advice to you learn AI. So and also search for skills that are really trending right now or that are somewhat have a higher chance of getting hired, even though it's going to be out of your comfort zone. So you may need to get out of your comfort zone. Let's say you're doing web development, right, or full stack development, but more on specializing in web development. So try other technologies, and then uh, in order to not get bored or not get burned out, even since you're going to study other technology that you might not be interested at all, try doing side projects. So let's say currently there's I actually seeing this a lot. Forward engineer, is is it engineer? This one, forward FDE. They are saying this one as a forward develop deployed engineer for AI, AI engineer, or for FDE. I think FWD or FDE. This one. So try to have this kind of skills. I think I've been seeing this a lot in LinkedIn. So I think it's somehow a software develop. I think it's composed of software development skills, but it knows how to also with the plus AI technology skills. And I think the focus of this one is to somehow in client facing, and then somehow doing integrations of AI. Hello, I live the Tura.
Oh, shoot.
How do I? But I think you can just copy this one. AI engineer. Let me try to. I think I'm more on 9 plus years. I forget my. I'm kinda. Though before I've been job hopping, but it's kind of stressful to job hop. So right now in my current employed, I try to stay as much as possible. But I'm not a specialized developer, so maybe I can call myself a generalist. 9 plus years. So that's why I'm trying to upskill more on transitioning to software architect level, since I think it's the right role that I need to go because of because AI is trying to conquer the coding part. But I still love coding. Just that yeah, it's just that I need to learn more. And software architecting is one of those things that I think the best fit for me. S- I was wondering if I can ask how to start coding. I think just pick a language, love Datura, and then you can use AI to craft your roadmap study. Entry level developer. I think just keep practicing, and then always be open to change or how technology flow. Though you don't need to follow the what is trending, but you just need to be conscious of the flow of the technology. So as possible, be informed. But the most important thing is keep practicing and keep learning. Though it's kind of tiring, but that's how it is. especially right now. It's super challenging. In even for senior developers, it's super challenging to also to get yeah, get employed. Uh, BSCSA. What is DSQ? I saw one. Also, what do you think about BSCSAI? Actually, that's the first time I heard BSCSAI. Probably a computer science with AI subjects. I think it's okay, probably, since it's kind of modern, since because of the AI part. But I hope it's just not just a marketing strategy of the school. I hope they are serious in teaching AI, not just how to use ChatGPT or something like that. I hope they also teach the fundamentals of how to develop AI applications. Huh. Convert this one. Ah, shoot. This is token IDs. I need to reverse this. Runtime token IDs. PPE runtime. Ah, no. This is vocabulary. Hmm. Get token by ID. Okay, let's name this one as token TID. I see. Oh, I don't need this one anymore pala. Get token by... I see. Tapos... I need to... Ah, okay. Gets... I don't know if I'm in the mood right now. Let's try first the input. I'm getting confused here. Get token by ID. Ay, ito pala. But I had a... Oh, okay. Wait. Uh-huh. So this is the token IDs. I had always. So this is the token. What's my input, by the way? Then this is for the... Get token by ID. Interesting. Vector of queue size. I don't know. Input score is... Okay. It's just a glitch on RAS Analyzer. Medyo weird lang tong part na to. Oh, kasi because of my context size and batch size, that's why it's kind of limited. So let's say if I increase this one to 10, I will have more uh, result here. Yeah, gets. But so my code for tokenization is correct since I was able to decode it. Okay, I think this is okay. So I think we can. So the source text you encoded is the opening of the verdict. That is our next topic. Okay, next topic is token embedding. You already completed the data pipeline. So, okay. So, we're now on token embeddings. Let's continue. Create token embeddings here. I will send the pages of it for it. Branch. What happened? Create token embeddings. The last step in preparing the input text for LLM training is to convert the token IDs into embedding vectors as shown in figure 2.15. I guess this one. As preliminary step, we must initialize. So this is the output text post-processing steps. GPT decoder transformer, token embeddings, token IDs, tokenized text, input text. Okay. Presentation involves tokenizing text, convert text tokens to token IDs, and convert token IDs into embedding vectors. Here we consider the previous created token into this embeddings weights with random values. This embeddings weight with random values. The initiation serves as a starting point for the LLM's learning process. In chapter 5, we will optimize the embedding weights as part of the LLM training. A continuous vector representation of embedding is necessary since GPT like LLMs are deep neural networks trained into with the back propagation algorithm. What is back propagation algorithm? What is back propagation algorithm? Backpropagation algorithm is used to train neural networks by figuring out how much each weight contribute to the final error, then updating those weights to reduce the error. In simple terms, which weights cause the prediction to be wrong and by how much should I adjust them? The basic flow. A neural network training step usually has two main parts. Input goes through the network, input plus layer 2 output prediction. Then we compare the prediction with the correct answer using loss function. Machine learning nga to. Loss, how wrong the prediction is. Backward pass or back propagate. The loss is sent backward to the network. Loss, output layer, hidden layers. Oh my god, this is confusing. I have no background in machine learning. During this process, algorithm computes the gradient of the loss with respect to each weight. Gradient tells us if I slightly change this weight, will the loss increase or decrease, and by how much? Then an optimizer, commonly gradient descent, ito medyo familiar ako dito, updates the weights. New weight, old weight, minus learning rate times gradient. Why is it called back propagation? It is called back propagation because the error signal is propagated backward from the output layer to earlier layers. The network produces an answer, sees how wrong it is, then sends the error backward to adjust the internal weights. Really, I'm only 30 minutes study. Parang, I feel that it's been a long time already. I've been studying. Long time I've been studying. 30 minutes pa lang pala, no? Fine example. Suppose a model predicts 80, actual 100. The loss says the model is wrong. Back propagation then checks weight A contribute a lot to the error. Weight B. I think this one is kinda, ano na siya. Decided that calculus gradient for every weight in a neural network by moving backward from the loss, allowing the model to learn through the gradient descent. I have no idea about that. But I think it's more on correcting, I guess. Anyways, I will go back again to the book. A continuous vector representation or embedding is necessary since GPT like LLMs. Okay. You're familiar with how neural networks. Let's see how the token identity embedding vector works. For the sake of simplicity, suppose we have a small vocabulary of 6 words instead of 50 keywords in the BP tokenizer vocabulary, and we want to create embedding of size 3. In GPT-3, the embedding size is 12k in dimensions. Okay, that's a lot. Vocab size, output. Using the vocab size and output dimension, we can instantiate an embedding layer in PyTorch. Okay, another library again. The print statement prints the embedding layers and underlying. So this is in tensor. Requires CRUD. The matrix of the embedding layer contains small random values. These values are optimized during LLM training as part of the LLM optimization itself. However, we can see that the weight matrix has 6 rows and 3 columns. There is 1 row for each the possible 6 possible tokens in the vocabulary, and there's 1 column for each 3 embedding dimension. Now let's apply it to token ID to obtain the embedding vector. I think I can skip this one. I just read the remaining explanations. For those who are familiar with one-shot encoding, the embedding layer approach. I wonder if I do manual embedding. I mean, if I create my own embedding. Let's try. Now we are now 2.7 creating token embeddings. Logic is moving. Token IDs embedding vectors. Before this section, your data looks like batch size and target. So this is the batch size, and then this is the token. This one is the context size. But those numbers are only IDs. They are not meaningful numeric values. Token ID is 100. Not greater than token ID 2. It's just that index into the... what am I reading? The page is moving from token IDs to embedding vectors. Before this section, your data looks like... For your current batch, yeah, okay, examples, yeah. But those are only IDs. They are not meaningful numeric values. Token ID 100 is not greater than token ID 2. It's just an index into a table. So the model needs an embedding table. What is an embedding table? An embedding table is a matrix. Vocab size, embedding dimension. In your tokenizer, vocab size is 104. Where that vocab size came from? Oh, I see. Because of the token ID. So the maximum token ID I have is 104, I think. And 10 token IDs. Yeah, this one, 103. So yeah, 104. Okay. Now choose an embedding dimension that uses small text sample like 3. Embedding dimension. So then your embedding shape is, so meaning 104 possible tokens, 3 floating point numbers per token. Okay, embedding table. So per row is there's a token. Okay, so when the model sees token ID 100, it will retrieve row 1. Okay, I kind of get it now. Token ID 100, embedding table 100. This is all the token embedding shape contract. Each value is a token ID. After embedding, okay. So like this one. So this is my runtime token IDs. So the token IDs will be Excalibur. Ah, throw na tayo. Okay, so here, this is the word, and then token ID. I need to assign index for token IDs. And then the embeddings is the numerical values for each token. So, ito yung parang, okay. I think this one is kinda tricky and confusing at the same time. How do I produce this? Is this just really a random numbers? Embedding dimension, yeah. That's challenge. The book uses p-writers. In Rust, you need make this explicit. So embedding weights. Use row major. So the weights is token ID times embedding dimension plus dimension. What is dimension? I don't know what dimension is. For embedding dimension is equals to 3. Let memory. Borrowed slice. Okay. This is kinda needs a lot of math. Okay. No, okay. So 2 minutes na lang pala ako. I think I need to end the stream. Probably I will try to do this again tomorrow. Or maybe later. Before I study software architecture, I will try to be early later. Plus 1 hour. So I will need to study full 3 hours later. 1 hour for this, and then 1 hour for software architecture later. 2 hours for software architecture. Well, I guess that's it, guys. See you